3.1, which is tangent lines and derivative at a point. So let's just kind of go through like the introduction of this like for just a couple seconds, and I'll go through some of your examples that you guys are asking. So 3.1 says tangent lines and the derivative at a point. So I'm going to kind of do a little mini lecture real fast of explaining what this actually means. So what we know is the slope of the tangent line at a point x equals x naught. So at x naught, the way we write this is, well, sometimes we just call it m because we're referring to the slope of that tangent line. So a lot of times I just write it as m. But really, this is the limit as h goes to 0 of f of x naught plus h minus f of x naught, all divided by h. Another way to say the slope of the tangent line at point x naught, instead of having to write all those words, is we could say this is also the derivative of that function at that point. So this is also the same thing as saying the derivative of f of x at x naught. So these are all the same things, okay? And another notation we can give for this, instead of writing it as m because that's so pre-calc, right? Okay, so instead of writing it as m, what we do is we write this as a derivative notation. Our notation is this little prime notation, this little Newtonian notation, f prime of x naught. So this f prime of x naught is the same thing as m. So all these things are equivalent statements, okay? So if I say the slope of the tangent line, or if I say the derivative at that point, or if I say f prime of x naught, or in this case, even if I say m for that slope of the tangent line, we know that this is all considered the same thing. And really, this expression right here is the limit of some funny-looking thing, right? Like this expression needs to be built, and then I take the limit of that built expression. All right. All right. So how do we find the slope of a tangent line? Well, we can kind of go through some of the examples, and they're kind of good. Just to give you like a pictorial representation of this, we can find the slope by hand just by a straight edge and a couple dots, but noting that this is going to be a pure estimation. So the first question you guys asked was number 3, like, let's find the slope at these particular points. That's what we're going to do, yeah. Well, let me show you guys. So I wish I want to draw on it, so I'm going to draw on it. It's a brand new book. I feel bad to do it, but so
you could do it on the board.
Yeah, but it won't be on the video, so it gives you guys something to look at. So it is what it is. So if I take a straight edge right here, do you guys agree that the edge of this is tangent to that particular point? And what I mean by tangent is, remember what a tangent of a circle is. So kind of going back to a tangent. If you had a circle, what we know is a tangent line at, say, this point right here. That's a tangent line. Oh, way off. You guys agree that this is our tangent line? This thing right here is our tangent line to that particular circle? And what I know is that that the radius and that tangent line make a 90-degree angle, right? So that's what I mean by a tangent line. So it's saying that it's kind of the same thing. Now, a curve's not a circle, but it can have very similar properties. So at that particular spot, for the theoretical circle that itty-bitty little spot makes, it would be 90 to that curve. Does that make sense? When you get to Calc 3, we'll talk about this theoretical circle, because that'd be the best way to describe tangents. Okay, so I'm drawing one of them. So drawing this one, you guys think that's pretty good?
Yeah.
It's going to be here forever. All right, I hope that was good. So, tangent, agreed? So what I want to do is I want to find 2 points on this tangent line that cross the intersection pretty well. I missed a little bit, but it's just me being me. So kind of zooming in a little bit better on this. What I'm looking for is I'm looking for intersections between these black lines. Now notice how as the student brought this up, which is a really neat idea, is notice how this is 1 unit, this is 2 unit. But if I just count the boxes, will I get the same slope? Yeah, you will, because they'll reduce to the exact same number, right? So it doesn't matter the size of your box. If you take a box that's 1 by 1, or if you take a box that's 1/5 by 1/5, The only thing is the other one's going to be 5 times bigger on the top and 5 times bigger on the bottom, right? So you can just cancel that 5. So you could just count the boxes for rise and run. It doesn't matter about the units, right? As long as the boxes are even, as long as there's 5 boxes per each unit. So it's kind of neat. So I'm going to pick 2 points. Do you guys agree that this point, notice this point right here, intersects a horizontal and vertical of one of the edges of the boxes? It's a really nice spot to pick. Because what I want to know is how many boxes over and how many boxes up. So I'm going to try to find another one. Actually, this wouldn't be a bad one, or maybe, I don't know, maybe that one. You guys good with that? That's another good one? All right, that's the best I got. Remember, this is an estimation. So if I find the slope of the tangent line, that's the same thing as the derivative at this particular point. So the derivative at this P1 is going to be the slope of this line through these 2 dots. Now remember, it's an estimation. Your line might not be exactly what my line is, but it's going to be darn close. You guys agree? All right, let's find the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got a rise of 9 and a run of 1, 2, 3, 4. So 9 over 4. Does that make sense? So for the solution to this, if I was going to write this in
Example number 1 anyway, because P1 is literally at 0.
well, let me answer your question. Depending on the point, you get a different derivative, right? A different slope.
The only thing I can think of for the line at P1 is literally a straight line across the vertical axis.
Let me answer this first. Number 3. So number 3 says, if I want to find the slope of this f of x at P1, I really had to draw that tangent line, right? Pick 2 dots on that tangent line. Does it matter what 2 dots I pick? Technically, no, right? I'm just trying to pick the nicest ones. Does that make sense? Even if you pick 2 other dots, you're going to get something similar to 9 over 4, which is about 2. So if you get any number that's close to 2, you got all the points, okay? Because it's an estimation. So what I got is m was going to be rise over run. So this was equal to 9 over 4. So the notation would be f prime of P1. Well, actually, I should say the x coordinate of P1. I should be a little more specific there. Let me write that. F prime of x1, which is the x coordinate of P1, is equal to 9 over 4. Does that make sense? Because you do f prime of x. It's an x coordinate. So in this case, what is the x coordinate here? P1's on what x coordinate? I don't know. Why do they have to go by fifths? It's 2/5. You guys agree? Because 1 unit is all the way here, so I don't know if you can see it. So technically it's I think that's supposed to be an f. It doesn't look like one. So this is f prime of 2/5 is equal to 9/4. The slope of the tangent line at the point that goes through 2, 5 is 9 over 4. What if I do P2? Well, P2 is, I don't even know what x value that is. Pretty close to 2. You guys agree? Okay, so I'm going to do a straight edge here. Do my best. Oh, is the slope going to be different?
No.
Well, let's see. Remember, this slope is positive, right? This slope is what? Negative. It's definitely going to be different. So, yeah, good enough. Oh well. Yeah, whatever. So, my dad always said is, we're not building a church, son. So, okay, so I'm picking 2 dots on here that look kind of nice. This one right here, I'm pretty happy with. You guys agree? Okay, and then also that one right there looks pretty good. Okay, so I'm going to do rise over run. So 1, 2, 3, 4, 5, 6 is a rise. And over here I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 over 9, about 2/3. Okay. So A, you have this. B is what I said, 6 over 9. Which is about 2 over 3. So that's what they're looking for. Looking for the slope of the tangent line. So now when we do this mathematically, you guys agree that these curves have some kind of form? This is probably some kind of cubic. This is probably like x cubed, quantity x minus 2 cubed plus 1 or something. It's a cubic that's been shifted to the right and shifted up. So the idea is if I give it to you in graph form, you understand that the derivative is the slope of this red line. It's the slope of the tangent line. Now, when I give it to you in expression form, can you still find the slope of the tangent line if I just give you an expression form as opposed to a curve? The answer is yeah, we can do that. And the way we do that is we use this thing right here. This tells you that slope. So this thing and what we just found are technically the same things. Does that make sense? Like this is a graphical estimation of what we're going to find exactly. Okay. So you guys asked number 9.
What is the rest of 3 say?
Oh. Use the grid. Says make estimate the slope of the curve.
Yeah, I'm not answer that. You go.
I got 9/4 for the first one and 6/9 for the second one. We simplified to 2/3. Well, when you
But
do
what
it,
about the,
remember when you do it yourself, you might not get exactly this answer. Just make sure that you're close. These are estimates. So you're going to create a straight edge, and you're going to do your darndest, okay? So as long as you get a close that's pretty close to 1 here and pretty close to, I don't know, 2/3 here, I'm happy with that. I don't ask you to do these on tests because I don't want 32 different answers.
2 estimating?
Yeah, 2 estimate. I like that. I'm going to use that. Okay, so me and the English language get along real well. All right, so number 9, because it's very complicated. 17, not bad. Okay. So, number 9. Oh, I know why I guys asked number 9 because it's ugly. Number 9 says, well, in this example, I want to write the. It says, find the equation of the tangent line to the curve at the given point, then sketch the curve and the tangent line together. Okay. So I'm not going to write that. That's what we're going to do. So if I want to find a tangent line, to f of x, which is equal to x cubed at the point -2, -8. When I'm asking to find a line, what 2 things do you need? I need a slope, right? I need a slope. And I also need a what? Okay, well the point they gave us, right? The point they gave us is going to be x naught comma y naught, which is equal to this -2, -8, right? They've already given us that. Now the slope, which we call m, has a better notation, right? This is f prime of x naught, right? That's our m, f prime of x naught. It's the derivative at that particular point. So when you see this f prime, this just means the slope of the tangent line. Slope of the tangent line to this function at this point. So x naught is f prime of -2. Okay, so we're gonna most of our work is gonna be finding this thing, right? Because they've already given us everything else. Okay, well, f prime of x naught is equal to the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. And we've already done this stuff. You guys agree? We've already simplified this expression.
Wait, isn't it supposed to be -1/3 because the slope's negative for 3?
Oh, yeah, you're right. It is negative. He's right. He got me there. That was down, right? Down 6, so that's -2/3. Yep, I was wrong. It's negative. Nice catch, by the way. So here's our So here's the equation of the derivative. Well, what do we know? X naught is what? X naught is -2, and it comes from the point that they gave, right? X naught's this -2. So this -2 here, which is x naught. So that's what's going to go here. So this thing is going to be -2. So plugging that in, limits as h goes to 0 of f of. So I got -2 for this one, I got -2 for this one, and this is all over h. All right, what do you do next? Yeah, you gotta use that letter F, don't we? So get rid of the letter F, and how do you get rid of the letter F? Plug it in. Yep, you evaluate the function. So what that means is this -2 plus h is going to go where? Yeah, into this x position, right? It's going to go into the x position, isn't it? And also this -2 eventually is going to go in that x position as well. Okay, so this is going to be equal to the limit as h goes to 0. Well, f is just x cubed, right? Minus cubed all over h, where the very first input is going to be -2 plus h, because that's what's going to go here in this x position. And the next one is going to be equal to this -2. I didn't want that, I wanted the green, but it's too late now. So then the next is going to be this -2, which is also going to go in that x position. So this is x cubed minus x cubed, where x's are equal to these things, right? All right, now this is where the fun happens. Because I have to simplify, right? Which means I have to expand the heck out of this thing. Is that clear? Well, how do you cube something? Well, the first thing is you start farther left on your paper. Okay, so you know this is going to be -2 plus h times -2 plus h times -2 plus h. And then you realize I had more left I could go on, but it's too late now. So that's what -2 plus h cubed is, right? So I'm going to have to multiply all those things. So then minus this, well, this becomes -8 all over h. So when you multiply things, we only do 2 at a time, right? So what I'm going to do is I'm going to do these first. I'm going to do these 2 first. And then I'll multiply the last one next, okay? So when you multiply, it's a multiplication's a binary operation, so you can only do 2 things at a time, right? So when you FOIL this is going to be, well, +4, right? So -2 times -2 is +4. Outside is going to give you a -2h. Inside is also going to give you a -2h, so a -4h. And last is going to give you an h squared. Clear? What do I still have, though? Yeah, -2 plus h. I still have this -2 plus h, so we're not done yet. I'm just going to say this is +8 over h. All right, multiply again. Now, I use the word FOIL there, but FOIL is just a name for advanced distributing. What you're doing for FOIL is you're taking this number and you distribute it over both of those, and then you're going to take this number and distribute it over both of those. You just take every term in this particular thing and distribute it over the 2, right? So when I multiply this, you're going to have to take this 4 here and you're going to have to distribute it over both of those. And then you're going to take this -4h and you're going to have to distribute it over both of those. And you're going to take this h squared and you're going to have to, well, distribute over both of those. Does that make sense? It's still got that FOIL type of look to it, but there's more letters now, right? Okay. So when we distribute this, this is going to be the limit as h goes to 0. Well, 4 over both of those is 4 times -2, which is -8. 4 times h is 4h. Now this -4h has to go to both of these, so -4h times -2 is +8h. And then -4h times +h is going to be -4h squared. And then finally I have to distribute this h squared over both of them, so I'm going to get a -2h squared plus an h cubed. And then I still have that +8. Don't forget this last term. People tend to forget that because so much work has to happen on this left-hand part of this expression. So don't forget that 8. Okay. Now what's supposed to happen is really nice things. Notice I have an h in the bottom, and when you're working with a polynomial, anything that doesn't have an h on the top is definitely going to go away. That's what's going to happen. So simplifying this, the 8's are gone, right? -8, +8. Okay. And let's combine some like terms. Let's start out with the highest power. So I have an h cubed. So that takes care of that h cubed. I have 2h squares, so -4 -2 is -6h squared. Expected a different number than that. Oh well. And then this is going to give me a 12h. And the last I have, I think I'm good. You guys agree? Okay. All over h. All right, I can live with that. So, what can you do with the numerator? Factor out an h. So if I factor out an h, I'm left with h squared minus 6h plus 12 all over h. So that means that h on the bottom, which is our treble factor, right, finally went away. So what does that mean I can finally do with 0?
Plug it in.
Plug it in. So this is going to be 0 squared minus 6 times 0 plus 12. Hey, I applied the limit. Do I have to keep writing limit? No, I plugged it in, right? You've just done the limit. Is that clear? So the question is, when do you stop? Well, you stop when you plug it in. Does that make sense? Okay. So what's left over? 12. Okay, so let me just make sure. 3x cubed, 3x squared, 4, 3. Yep, we're right. We got it. Okay, so there's a quick way to do this. I just did it in my head. So I'll teach you guys that in a week. So that is f prime of negative 2. Does that make sense? Okay, so now I need to find the tangent line.
Excuse me.
Yeah, no, what's up?
So where did you, for number 3, how did you get that fraction that you put in for x when you said that f of 1 times x1 equals the 9 4-ish?
See you on break. I'll show you. Okay. So the tangent line says y is equal to m times x minus x naught plus y naught, right? That's our kind of like a pre-calc version of that. I would actually prefer to use this notation because m is actually f prime of x naught times x minus x naught plus y naught. Does it make sense that our that this 12 is just the slope of the tangent line, right? That's going to be our m. Does that make sense? Which is the same thing as f prime of x naught. So that thing right there is just a number. It's just m. And then your x naught comma y naught, well, your x naught comes from that, from the point that they gave you, and then your y naught comes from the other point, right? From the y coordinate of the point. So what's m in this case? What's the derivative? Okay, so it's 12 times x minus negative 2. It's supposed to be in green. Negative 2. And then plus what's y naught?
Negative 8.
Plus negative 8. Okay, so cleaning this up, this is going to be equal to 12 times x plus 2 minus 8. So this is equal to 12x plus 24 minus 8. So y is equal to 12x 16. Agreed? This is what they're finally asking for. All right. The last part they asked for is they wanted a graph. So we're going to do that for them, okay? And I just want to make sure that this makes sense, okay? So knowing that this is, I'm just going to flip over the paper and then I'm just going to do a graph. I'm going to write the function. I'm going to write the tangent line and just see if it lines up. So what they said is we were looking for f of x, which is equal to x cubed, at negative 2, negative 8. So this was that particular function. So x cubed is, we all know that it looks like this, right? It's one of the functions you were forced to memorize in pre-calc. Or you could just put it in your calculator and hit enter. So there's x cubed. We are also asking about the y is equal to 12x plus 16. What do you think's happened if I graph the two to each other? Well, negative 2/8 is going to be, I should have did a little better job of this. There's negative 2. Oh my god, this is failing badly. Whatever, it is what it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so just going to have to just pray a little bit. So you guys agree that that would be negative 2, negative 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I graph this line, what's going to happen is it's going to end up being tangent to this curve here. And it's going to rock. The reason I'm picking 16 is because I know it's got a y-intercept of 16. So that's what it's going to look like.
Move it down.
Oh, there you go. So I know that this blue curve, which is the tangent line, which is equal to this thing, is going to be tangent to our function at that point right here, negative 2, negative 8. And I know it's that blue line is going to go through 16 because it's got a y-intercept of 16. So that'll just happen. And honestly, if you look at the graphs, you can even graph it on your calculator, it'll look as pretty as it looks. I mean, as pretty as it can on a calculator. All right, let's do a couple more. Number 17 says, Number 17 is, this next section is asking quite literally the same thing, except they just don't want you to graph it. They just say find the slope of the tangent line, and then find that tangent line. So find the slope of the function's graph at the given point, which means slope of the tangent line. Then find the equation of the tangent line of the graph there. So up here they want you to graph it. Down here they just says give me the slope of the tangent line and we're done. So f of x is equal to the square root of x. At what, 4, 2 or something? Yeah. At 4 comma 2. So if I want to find the slope of the tangent line, how do you find the slope of the tangent line? How do you find this m? It's going to be f prime of x naught, which is equal to the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. What's neat here is you see two different variables technically, right? You see x's and h here, but x naught's a constant, isn't it? So as soon as you stuff in that x naught, the only variable that you have in this expression is an h. So this ends up being a function of h and h alone. So that's why you simplify it as h was a variable. So what's x naught? 4. So this is our x naught. So we're asking for f prime of 4. F prime of 4. So this is going to be the limit as h goes to 0 of f of 4 plus h minus f of 4 all over h. So 4 goes here. So it's going to go in this location right here. Ooh, careful! You can't root additions. The square root of a plus the quantity square root of a plus b is not square root of a plus square root of b. It works for products, but not additions. We have to be a little careful with our algebra.
Well, h is 0. So.
H goes, well, we can't plug it in yet. Let's kind of talk about what happens first. So, you guys agree we got to get rid of the letter f, and we do that through evaluation? So this 4 plus h is going into this x position right here, right? It's going to go right here. Okay, so this is going to be equal to, so this 4 plus h is going in that x position. So this is going to be equal to the square root of 4 plus h. Minus, I have to do the f function again. Well, the f function is the root function, right? That's f. But what goes in there now?
1.
Just 4. So this one goes here, this one goes, these are just going into here, right? Through that expression. All over h. All right, so then we're going to simplify as much as we can and see if we can just plug in h equals 0. Because that's kind of the hope, right? Like, please let me be able to plug in h equals 0. But can I plug in h equals 0?
No.
Because the bottom would be 0, right? So how do you simplify things that have radicals if you can't plug them in?
Square.
Conjugate, yes, conjugate. So what's the conjugate of root something minus something?
Plus
Root
something.
something plus something.
Root something, this is supposed to be a 4. Plus h, root something plus that something, right? Boy, I should say words instead of somethings. Okay. I'm glad I'm writing it down at the same time, because if this was an audio only, it would be, it'd be awful. Okay, so what do you multiply? Well, you technically multiply both, but what are you going to combine when I do multiplication? The numerators or the denominators? Yeah, you do the conjugates because they multiply nicely, right? The denominators, you just leave them in parentheses as a multiplication. So since this is, what's root something times root something? Yep, that radicand. And then outside and inside for conjugates will always cancel. So be careful. This only works with conjugates. Don't cancel outside and inside every time. All over, we're leaving these alone, right? Okay. What's nice is once you simplify, everything in the numerator that doesn't have an h eventually goes away, right? That's kind of the goal. Because I'm trying to get rid of this h on the bottom. And we can see that those 4s, well, the 4s go away. 4 minus 4. So you're going to get h all over h times the square root of 4 plus h plus 2 quantity. There we go. And now the h's cancel. What's left in the numerator?
1.
Good. So this is the limit as h goes to 0 of 1 over the square root of 4 plus h plus 2. Now remember, you're allowed to plug zeros in the bottom as long as the bottom doesn't become what? 0. Okay. Because again, what are you never allowed to write on my test?
0 over 0.
Okay, so 1 all over the square root of 4 plus 0 plus 2. If you write 0 over 0, how many points are you going to get?
0.
2 plus 2. 1 over 4. You guys agree? Okay. All right, so that's, remember that 1/4 represents that slope of the tangent line at that particular point. So what's our tangent line? How do you y equals f prime of x naught times x minus x naught plus y naught, right? M times x minus x naught plus y naught. That f, this right here is just a slope. Don't be afraid of it. What number is this?
1/4.
Yeah, it's going to be 1/4 because f prime of x naught or f prime of 4 was 1/4. X minus, what's x naught? 4 plus y naught, which is 2. And then we just multiply. 4 times x minus 1/4 times 4 is 1 plus 2. So this is 1/4 x plus 1. And again, if you did want to graph, it's not asking for it, but I just want to show it over here. If you did want to graph this thing, you know that the square root function is this thing, right? It's half a sleeping parabola.
Oh.
You know that we're going to go through the point 4, comma 2. So 1, 2, 3, 4.
You want
1,
us to
2.
sketch the
I
line
don't. I just want to make sure that this makes sense, that that's the case.
For numbers 5 through.
Yeah, because it asks for it. If it's in the instructions, please do it.
um,
So then when you graph this, you can see that this is going to be the tangent line, isn't it? Is that clear? And that's that, you know, that's that y is equal to 1/4 x plus 1, where the green one is, this is y equals root x. And you can see that this point right here is the point that crosses that 4, comma 2. Questions? You guys agree it's not that bad? Once you write this expression here in h, you know, once you write this expression, it's just like we did, you know, it's what we've been practicing for a month, right? So honestly, this is just a function of h once you're done, you know, once you're going from here to here. All right, growth of these cells. So eventually kind of asks, like, why do we need all this stuff? Well, Newton created calculus to do physics. Because we know a lot of things move at a constant rate, but in general, do things move at constant rates? No. So to know their speed, or like even on your car, like when you look at your speedometer, your speedometer is quite literally telling you the derivative. It's telling you your rate of change at a particular value. So we need to know stuff like that. We need to be able to figure those things out. Actually, if you you know how you can get a ticket if you like if you slide too far, you know, like while you were speeding. What they know is your deceleration took too long to get from point A to point B. So if they know how long it took you to stop, they can actually interpret your previous speed, and all that's through derivatives as well. Yep, that thing's broken.
What was that?
No, was the key word. So that's right.
What do you mean the keyword was?
I killed it. I broke it. No, I think it's gonna make it. Clear? Okay, I got it. So, back to estimation. It says, in a controlled laboratory experiment, yeast cells are grown in an automated cell culture system that counts the number of P of cells present at hour intervals. The number of hours T is shown in the accompanying figure. Okay, so explain what is meant by the derivative P prime of 5. So, I'm not drawing on this one, but I'm going to kind of show you. So when they ask you for P prime of 5, remember, when you say P prime, what are you actually talking about? Please say slope. Okay. Slope. So we're talking about the slope, and the slope at what x value?
5.
At 5. So I'm looking for the slope at x equals 5. So really it's the intersection of that function. It's the intersection of that function at 5, right? So this right here is the point they're talking about, right? It's that point right there. Now I want to know the slope of that point, the intersection of x equals 5 and the function. Well, the slope is going to be the slope of this, whatever, it's only a book, right? So, that right there is our tangent line, right? This is our tangent line. So p prime of 5 is the slope of that red tangent line. So the way we can find the slope of that tangent line is to guess, right? What's its rise over run? I don't know. Let me just pick a couple points. Okay, I'm gonna start here and here. Because I don't see any really nice intersections. You guys got any? So do our best. So I'm gonna pick this point, and I'm gonna pick this point. So that looks like about 225. You guys agree for a y value? And maybe 60 for the y value of the other one? Okay, so I'm gonna write it down over here. So for A, I know p prime of 5 represents the slope of the tangent line. I'll show you guys what I'm writing in a second here. And I know that this is going to be rise over run. And I know that the rise is going to be 225 minus about 60. This is flat guesses, okay? So the derivative of p prime of 5, well, p prime of 5, which is the derivative of that 5, is that p? Yeah, okay, so the function's p, which is the slope of the tangent line, which is going to be rise over run, which is, the rise is 225 minus 60, right? y2 minus y1. Now for x2 minus x1, x2 is 7, x1 is 4. 7 minus 4, and then we're just going to kind of hope a little bit, right? See if we get an answer that's somewhat close to what they're asking. Minus 60, I get 165 all over 3. So I get 55, that's nice. So I get 55. So what I have is I have that 165 over 3, which is about 55. So, and what are the units? That's a good question. What are the units?
Cells per hour?
No, for p prime. Well, what's the units of the rise? P. So I think p is number of cells, right?
Yes.
Exactly. So this is going to be number of cells. Now per, which is that divided, means per. What's the denominator? What's t represent?
Hours.
And hours. Yep. So hours. So when you simplify this to a unit factor, because this is 55 over 1, right? When you simplify to a unit of time. So that means this is increasing at 55 cells per minute at this particular time. Does that make sense? Like if you want to know, like you guys agree that the cells are increasing over time? But if you want to know what's its increase at that particular exact time, well at 5 hours, it's increasing 55 cells per minute, per hour. Does that make sense? You can see that actually the more cells you get, the faster it increases, right? Because it's exponential. Okay. So this is cells per hour. So it's really the speed. It's the rate of change. It's how fast it's growing. Which is larger, p prime of 2 or p prime of 3? So if you're looking at p prime, 2 is going to be the slope of that tangent line, right? 3 is going to be the slope of that tangent line, right? What's got a larger slope? 3, okay. Because the slope, because it's, well, clearly because it's increasing, right? This function's increasing, therefore the rate of change is increasing. The quadratic curve capturing the trend of the data points. Oh, they said it's quadratic. Fine. So what they did is they curve fitted these points. So you can do this as a scientist. You can ask your calculator to say, hey, what's the best polynomial for this particular curve? And what it'll do is it'll use it'll use these points and it'll fit it to a nice curve. So the curve that's written is this thing right here. It says find the instantaneous rate of growth at t equals 5. Oh, we're going to find the exact answer here. Okay. My claim is 55. We're going to know how good I was, right? Because I'm going to find the exact. Okay, so we're gonna fly here, okay? I've done enough of these. So so b p prime of 3 is bigger. I'm probably gonna have to zoom out because I'm gonna have to get. This is gonna be. Okay, so b p prime 3 bigger because it is. So c, it wants to know the instantaneous rate of change. So this is going to be the limit as h goes to 0. Sorry, p prime 5 is equal to the limit as h goes to 0 of f of x naught plus h minus f of x naught, all divided by h, right? But I'm sorry, what is x naught? 5. So really, I only need to put 5s in there. Is that clear? Okay, so plugging that into that function, remember that, so note that f of x is equal to 6.10 times, they say it's in t. I'm writing x though, because I've already read it. X squared minus 9.28 times x plus 16.43. X really should be written as t, that's my bad, but it doesn't matter. Because really the x or the t value is 5, you guys agree? Okay, so this is going to be equal to the limit as h goes to 0 of, well 5 plus h is going to go into all of these things. 6.10 times 5 plus h squared minus 9.28 times 5 plus h plus 16.3 minus the quantity 6.10 times 5 minus 9.28 times 5 plus 16.43 all over h. You guys agree with that? So
lot.
it's big, so just like I said, follow along. You don't have to write it down. It's all videoed, so just make sure this makes sense to you. So I'm going to do this multiplication a little quicker. So I'm going to FOIL that because this is 5 plus h times 5 plus h. So when you FOIL that, you're going to get 25 plus 10h plus h squared. That's this piece right here. Minus 9.28 times 5 plus h plus 16.43 minus 6.10 times 5 plus 9.28 times 5 minus 16.43. I'm just distributing this negative sign. Just get rid of parentheses. All over h. So limit h goes to 0. I need a calculator. So multiplied here, I get 152.5 plus multiplied by 10 is going to be 61.0 times h plus 6.10 h squared minus, distributing there, 9.28 times 5. I get, that's not right. So I get 46.4 minus 9.28 times h plus 16.43, then cleaning this up, minus 6.1 times 5 minus 30.5 plus 46.4 minus 16 points. Only thing making this messy is the decimals. You guys agree?
Should that be 5 squared on the right? It should, yeah. 6.1 times 5 squared.
Oh, it's going to change so many things. I'm going to fix it. It changes this number right here, right?
16.
Yeah, it's going to change this 30. You guys agree? So this number is going to change a little bit. I'll fix that. Because that's going to turn into a 25, right?
Yeah.
So 6 point, thank you for catching that, 0.10. Well, I would know in a second here because all the h's won't cancel the way I need them to, times 25. So I actually get 152.5. That's good. 152.5. Okay, let's get rid of stuff because I don't want to write that anymore. So I have a 152.5 and I happen to have a negative 152.5, right? I have a negative 46.4, I have a positive 46.4, right? I got a positive 16.43, and this is supposed to be a 3. I lost it in the other paper, but this is 4.3. So this is a negative, this is a positive. And everything left has a what in it? as an h. So 61.0 times h plus 66.10 h squared minus 9.28 h. Everything else is gone, right? I guess I could have combined the first and the last. (61) minus 9.28. So I get 6.1 h squared, and these two things will combine to a positive 51.72 h. You guys agree if I cancel an h is going to go here, here, and here? Okay, so this is going to be the limit as h goes to 0. Pulling out h, I'm going to have h plus 51.72 all over h. So those are going to go away, and when I plug in h equals 0,
Wouldn't you have 6.1H?
oh yeah, you're right.
6.1H.
6.1 times h, right? So this is going to be 6.1 times 0, right? So what I'm left with is 51.72. Was my answer at 55 pretty good? Not bad. Okay. All right. So that's all the time I have. We're gonna take some questions from the other section, and I'll post this. 46 minutes. Okay.